Alright guys, section 8.4. And by now I'm going to really start looking and seeing, are we really struggling with the math? Because if we are, then I'm going to have a worksheet that just works on getting from like grams of one substance to grams of another, because it's going to be something we keep seeing. So in the last section here, section 4, we stay true to form, we're staying in the math side of things, and we're still using that grams of 1 to moles of 1, moles of 1 to moles of 2, moles of 2 to grams of 2. Okay, so, but before we get into that part, let's look at it in like a real world type of situation that you guys might see. So percent yield is if you made a 60 out of 70 on a test, what is your percent? So most of you can figure out your grades. You can see like on a test, oh, I made this, and you guys can get a calculator out and you can figure it out. So how would you figure this out? Well, most of you are going to take 60 divided by 70, and you would get 0.85714, and some of you would know to move this decimal point 2 spots over, or some of you might just do the 60 divided by 70 times 100, and that will give you 85.7. Okay, so that's the percent you made on the test. And like I said, I think a majority of the high school students know how to do that to find their grade. So let's look at it again using these s'mores pops. We were really into this, and like I said, we got to eat them and all that. So we know the s'mores pops recipe, we've been using it. So in theory, we should be able to make how many s'mores pops? Well, in theory, if I have 24 marshmallows, 1 chocolate bar, and 4 graham crackers, in theory, I should be able to make 24. Just like in theory, when I make a batch of cookies, it should be 60 in there. That doesn't mean I'm always going to get 60, because there's probably a good chance that I'm going to eat some of the dough, or my daughter will. So in theory, we should make 24. Did you guys start eating some of the chocolate bar while it was heating up? Or were you eating some of the marshmallows out of the bag while we were waiting? Last year during 4th hour, we actually on accident burnt half of our chocolate bark. So how many s'mores pops do you think we were able to make? Well, if we burnt half, and we normally can make 24, and we burnt half of our chocolate bark, then we're going to make half of our s'mores. So using the information from the test question, what do you think our percent yield of s'mores pops was? So if I'm looking up here at this, I put what I made versus what I could have made. So I'm going to do the same thing here. I'm going to make what I made over what I could have made. And I'm going to multiply by 100. So now that's going to be 50%. Okay, so we're going to do the same thing in chemistry. Only, once again, we don't always use nice, neat numbers like doubling or halving. Or of course, we're going to get some weird numbers in there. So let's look at this one. What if we were only able to make 10 s'mores pops? What would our percent yield be? Well, it's the same thing. What I made versus what I could have made. So what I made was 10. What I could have made are 24 times 100, and that is going to be 42%. All right, we're going to do, like I said, the exact same thing. So you can see where we're going. We're going to have a chemical reaction. And, okay, this is what I should have made with all these chemicals I had, but is that what I did make? And we'll do a lab with that. And even if you, or we're hoping you guys are still here, but those of you that are on remote learning, even if you aren't here, we'll do a lab, and I will do the lab myself and post pictures, post the results so that you guys can fill in your worksheet. All right, so percent yield. This is going to be important, especially if we get back here and we have a test while you're in school, because then if you're with me, you can have anything out. You can have anything out anyway, since it's kind of a weird year this year. But normally what I would tell them is that you can have this on your periodic table, which you can have out for tests or anything. So you're going to have actual over theoretical, and then multiply that by 100, and that's going to give you your percent yield. And that's what we've been doing so far. What did you actually make versus in theory what could you have made, and then multiply by 100. All right, so normally this is where I would ask you guys in class, what does it mean? What do you think it means, theoretical? You have to think of the word theory, in theory. So it means what we should make in a perfect world, theoretical yield. a perfect world. I don't know how many of you bake brownies, cookies, and you get every last inch of dough or batter, and you're able to cook every little bit. You haven't ate any, you haven't left any in the bowl, you didn't leave any on the stirs. You got all of it. That never hurt. I mean, I can't ever know of anybody that can get every piece off of that, the stirs. So you're never making 100% of what you can. Now, the actual yield is what you actually make. So half the battle with the chemistry side of things is being able to figure out which number is your theory, like in theory you should have made, and which one is what you actually made. So that's going to be the first step when we're looking at the chemistry side of things. So let's go over to the next page. Okay, so without proper ventilation and limited oxygen, once again, kids get kind of, they think too much into those words. Really, it's just telling you like, hey, you have everything you need. The reaction of carbon and oxygen produces carbon monoxide. So it's a lot of wording to tell me, hey, this is happening. So they want to know, what is the percent yield if 40 grams of carbon monoxide are produced when 30 grams are used? Okay, they want to know what number will we use as the actual yield. What did you actually produce? And that's what I'll say a lot of times. We have two numbers here. Which one did you actually make or produce? And if you look, it says 40 grams are produced. So I'm going to use 40 grams here. And if you notice, it is CO. Just like last section, we're always looking at how much is made. We want to know how much was made, and that's your product. And CO is my product. So that's another way to know what you actually made. So if you look at this, this is one of the reactants. So I need this reactant, I need it to be in grams of CO. So that's what I gotta get to. So yes, I'm having to go from grams of one to moles of one. Moles of one to moles of two, moles of two to grams of two. So hopefully you have written that down. I've written it down a lot of times, so hopefully you have it down. All right, so what number will we have to convert to find the theoretical yield? We will have to convert 30 grams of O2, and I will need to convert that into grams of CO. Now, we're not going to do it on this problem. It was just me getting you guys used to being able to seeing two numbers and figuring out which number we're doing what with. So let's look at the learning check. When nitrogen gas and 5 grams of hydrogen gas are mixed, the reaction produces 16 grams of ammonia, which is NH3. What is the percent yield of the reaction? So I have two numbers here. Now, one way is to read it and say the reaction produces, this is what you actually produced. The second way is to go and say, okay, which one of these has my product? And it is this one. So that is what you actually made. All right, so then I'm going to have to use the 5 grams of H2, and I'm always going to my product. I've got to figure out my grams of my product. So it's going to be a 3-step problem because I have to go from grams of H2 to moles of H2 because I can't go straight from grams of hydrogen to moles of ammonia or grams of ammonia. So hydrogen is 1, but there are 2 of them in 1 mole. All right, now I can switch over to my product. Moles of H2, moles of NH3. Anytime we have a mole to mole, you're using your equation. So there's 3 hydrogens for every 2 ammonias. Then last step, moles of NH3, grams of NH3. And 1 mole, nitrogen weighs 14 and hydrogen weighs 1, but there are 3 of them. So that's going to be 17. So when you take 5 divided by 2, multiply by 2, divide by 3, and then multiply by 7, you get 28.3 grams of NH3. Now this is not your answer. This is the theoretical. This is in theory, you should have made 28.3 grams, but what you actually made was 16. So now we want the percent. And remember, percent is always actual over theoretical. What you made versus what you could have made. So and then multiply by 100, sorry. So 16 divided by 28.3 times 100 is going to give you 56.5%. Not a great yield, only about half. But that's how you do these problems. So we have step one. Step one is always going to be, okay, I've got to figure out in theory, how much product should I have made? And then I'm going to do step two, which is the actual over theoretical. Now, sometimes they will be nice, and they will give us this number right here in the problem. So we don't have to do any conversions. We just do the the division, and we're done with it. It's a one-step problem. So anyways, let me know if you're having trouble with that. Like I said, I'm really going to be looking at the math side of things and seeing if we need just a worksheet without percent yield, without limiting factors, without any of that, and just going, okay, I have 10 grams of this. How many grams of this is going to make? Okay, I have 1.2 moles of hydrogen. How many moles of NH3 is that going to make? So that worksheet may have already come by this point. It may be coming. I don't know. We'll just kind of see how you guys are doing. All right, let me know if you have any problems, and I'll get back to you.